Hello everyone. In this video, I'm going to walk you through the PE1 case study given by Upgrad, or as it's called, the HR analytics case study. So the problem statement here is that XYZ company, the HR department of XYZ company, uh, have hired us because they are facing a problem of employee attrition, or in other words, high attrition rates. So their company has a current strength of around 4,000 employees, and every year around 15% of the employees leave the company. Now this causes various problems to the management because new employees have to be brought in, they have to be trained, so there is a downtime in productivity obviously, and also the loss of a large number of employees per year is bad for the reputation of the company, or the employer. So they've hired us to tell them which are the major factors responsible for this attrition rate, and how might they recommend remediate this problem. So for this purpose, they have given us a 6 different data sets. For example, they have given general employee data, which contains the employee IDs, the age of the employee, their gender, what is the salary, and their drawing monthly, etc. Then they have given 2 data sets for the manager survey and employee survey. So manager survey basically tells what rating the manager has given to the employee, while the employee survey talks about is from the employee point of view, where they give their opinions on the work-life balance, the uh, work-life balance, how they like working at the company or not. So those kind of things. There is also 2 data sets called in-time and out-time data sets, which contain information about how much time basically the employee is spending daily at the company. So our first task would be to, of course, join all these data sets using proper attributes in order to generate a master data set for our analysis. So once this is done, we have to predict the attrition, whether a given a certain data about an employee, whether he is likely to churn or not. So obviously this is a classification problem because the attrition is either no or yes. So in this case, we are going for a logistic regression model because of it is logistic regression is one of the simplest models to explain. It is pretty intuitive to business users, and also the data set here is not too large and doesn't contain too many variables that we need to go for, say, advanced more classification techniques like decision trees or SVMs, etc. So that is not required. So first step in the logistic regression is to clean the data. We have to convert all the variables to dummy variables. I mean all the categorical variables to dummy variables. So also the output of a logistic regression is probability values. Like given each data point for an employee, the logistic regression will tell what is the probability of that employee to churn. So we have to select a cutoff probability beyond which, uh, if the probability is beyond that, then we would say that the employee is going to churn, and below that, if it is below that, we would say the employee would not be going to churn. So how do we choose the cutoff probability? Well, I'm going to come to that later. That is part of basically model evaluation. So once we've done the data cleaning, we split our data set into training and testing data sets. We can use the sample or split function in R to do that. Uh, After that, we do an iterative model building process using the GLM command in R. So to do the model building process, we first build an initial model with all the features selected, and then we eliminate each of the variables which are not significant one by one. So this is the backward selection model. So variables are eliminated here based on the VIFs and p-values. Yeah, a high VIF value would indicate that the variable is multicollinear, while a very high p-value would indicate that the variable is insignificant. we have to look at both of these factors simultaneously to decide whether we should keep the variable or we shouldn't keep the variable. So once I build the model, the next step is to evaluate the model. We'll do that once all the significant variables are obtained. So we can evaluate the model using various measures such as accuracy, K statistic, lift, sensitivity, etc. So accuracy is the simplest measure, which tells what percentage of uh, responses are predicted correctly, but it is not very good. Why? Uh, we can explain that in an example. So if a data set say has 97% of responses as predicted as churns, as non-churns, and 3% as churns, and my model which I build says that there will be no churns at all. So even such a model will have a 97% accuracy, which will be misleading. So instead we look at some of the other measures which can give an idea of the discriminatory power of the model. Discriminatory power means how well the model differentiates between the various classes, the yes and no's. Okay, so some of the examples of this measure are K statistic, RSA curve, AUC, etc. So one of the best measures which I have found personally is the K statistic. So in order to find what we do in order to find the K statistic is we group the entire data set into 10, 10 groups of observations, or what is called deciles. Then we arrange it in a descending order of churns. So the higher deciles capture the more churns, while the lower deciles have the non-churns. So ideally, a good model should capture all the churns at the top, and the non-churns should be left at the bottom. So K statistic is the percentage difference between the cumulative churns and the cumulative non-churns. So it should be high for a good model. The ROC curve is a curve between the graph between the sensitivity and the specificity of the model, and ideally it should form something like a right triangle. Okay, with an area under it as 1. So a random model would just be a straight line between the sensitivity and the specificity, while the ideal model would be a right triangle. Actual models are somewhere in between, and the AUC of a good model should be high, as close to 1 as possible. So using these measures, we select a good cutoff value. We can select a cutoff value which has a high case, perhaps, or we can select a cutoff value which falls at the intersection of the sensitivity, specificity, and accuracy, whatever suits our purpose. So ultimately, after doing that, we create the final model, and we use it to predict the churns and the non-churns of test data. So in our particular case, the variables which we found, some of the variables which we found are like age, the number of companies the employer worked, then the environment satisfaction, job satisfaction, work-life balance, etc. So based on our findings, we made some recommendations to the HR of XYZ company. Basically, how they can keep their employees by trying to improve their job satisfaction. They can look to hire employees or whose age is more. Those kind of employees will be more stable. So these kind of recommendations. That is it for the PA1 case study. Thank you for watching.